Hello everyone and welcome to our YouTube channel. We are working on a series of videos on MPI and this is our second video on the topic. If you haven't checked out the previous one, do watch it to get a better idea of MPI. So without further ado, let's get right to the topic. Today we are studying point-to-point communication. So what exactly is point-to-point communication? So if you remember in the previous video, I said MPI creates multiple individual processes which are independent to each other. That means they do not communicate to each other during their operation. So what does point-to-point communication achieve? It helps us to send data from one process to another. So very simple definition. We can use the MPI send and MPI receive functions to transfer data between two processes. And why is this required? Because two processes in MPI are independent of each other. So this is the demo program of it. It's pretty much the same as in the previous one. MPI com rank. I'm storing the ranks of all the processes inside this variable. It's a pointer to this variable. In MPI com size, I have com word. So com size means I am storing the total number of processes inside this variable. That's the pointer to this variable. So it's an if statement. If rank is equal to 0, what I want to do, I am allocating a variable number is equal to 100. And I'll print a statement that this number is being sent to the other process. I am working with two processes here. One is rank 0 and one is rank 1. So even if I were to initialize this program with let's say 4 processes, it won't work because there are commands for only rank 0 and rank 1. Other rank 2 and 3 will be useless. So printf process %1 %d, this will be replaced by rank 0, sending number, so number as in 100, so that will be replaced by 100 to process 1. Process 1 will be process with the rank 1. MPI send, I will send it to this. So and number, so that means it's a pointer to this variable. And there's one means I'm going to send this data, whatever is stored at this location, to one MPI int, because I want to send it in the form of integer. 0 means I'm sending from 0, and com world means both the processes are the part of the community world. Similarly, we have here MPI receive for if in this one, if else if rank is equal to 1. So that means we have to write for the other process, because if process 0 is sending something, the other process has to receive it as well. The format is pretty much the same. I'm receiving this @ number, so that means whatever is stored at that location will be sent here MPI int. That means I'm taking it the value as integer and I am receiving it from 0. Com world means I am from both the processes are part of this this community, com world. And then I'm printing the output from thread 1. Okay, so let's see a live example of it. Let's move to the HPC. I am logged into a HPC param rudra, and currently I'm inside the login node. So before we try to run anything, let's move to a standard node. What do I mean by standard node? It's basically any node inside the CPU that does not have a GPU is termed as a standard node. So since we are working with MPI right now, only MPI, we can work with. We work with only the CPU. So that's why I'm going with the standard node. -pty/bin/bash. So this is the command for, okay, so this is the command for allocating a standard node for our use. -n, capital N, 1. That means I want one node to be allocated. -small n, that means the number of processes or the number of cores I want. -p, that's for the partition I want to work in, standard CPU and high memory. We have these partitions. Since I have chosen standard, so CPU and high memory are both cumulatively called standard partition. And this is for the slurm script, because this HPC has slurm as its manager. So this is the syntax for slurm that's required for this. Okay, so right now we are inside the node RPCN 059. So since it's written PCN, that means we are inside the CPU node right now. And let's start first. I need to load Open MPI 4.1.6. Okay, this is to run the MPI. I need this module. Okay, and now let's go to the directory MPI programs. Now we can compile the program MPI C++. Since my program is a C++ program, go MPI point-to-point.c. Let's run the program. Okay, program is now compiled and we can run the program using MPI run. And since we have a limitation on the number of processes inside this program, if you remember correctly, I'll show it to you once again. This is the program. So there are only two processes that are required, rank 0 and rank 1. Anything else and it will omit it. So let's try to run this program without any defined number of processes. Let's see if it runs at all. So yeah, it ran because I have already defined my need. I need rank 0 and rank 1 for this. Even if I had to find something higher, let's say -n4, it will give me the same output because I only need these two. Now this warning, you can ignore it. This warning is for the MPI tries to access the InfiniBand to connect to the other nodes, but since we do not have anything that requires the other node to be connected, it fails. We can very easily remove this warning as well. We can use this to run the program instead. MPI ---MCA. It's quite a long launch code. And if I run using this, I don't get the warning. It suppresses the warnings. It suppresses. It basically tells MPI, please don't do this. It's worthless. It's not included in the program. And just run the program as is. So I get process 0 sending number to some number 100 to process 1, and process 1 received number 100 from process 0. So how do we know the program is actually working? You can ponder upon it. You can ask, right? How do we know if it actually is working? Well, it is working because I told you before in the first video, each process in MPI is an independent process, means nothing is shared by default between two processes. And if I have defined the value of this variable inside of a loop that requires it to be in the process 0, requires it to be included, that requires to be executed by process 0. That means only process 0 can access this entire loop. No thread can access this loop. And that implies that rank 1, the process 1, cannot access this loop. So the only way it can have access to this information is when I specifically provided it. Without that, it would have been a blank number. We can test it right now. Let's just remove this and see what gets printed. Oh, first I'll need to compile it. Then I'll have to run it. Okay. So see, process 1 received number 0 from process 0. See? Okay, let's clear it all so it becomes much. Process 1 received number 0 from process 0. See, process 0 sending number 100 to process 1. So process 0 sent number 100 to process 1, but process 1 didn't receive anything and it just printed number 0 because I had commented the received part. So it shows that the two processes inside MPI are actually independent, and if you want to share any kind of data between them, you need to explicitly achieve it by MPI send and MPI receive. That is it for this video. Thank you for watching.